The topic for today is Stadia theory. So let's talk about some terms before we go into computation. So Stadia is a tachyometric form of distance measurement that relies on fixed angle intercept. So later on, you'll see what that fixed angle intercept is. So tachyometric form, so that came from tachyometry. And tachyometry is the procedure by which horizontal distances and difference in elevation are determined indirectly using subtended intervals and angles observed with a transit or theodolite on a graduated rod or scale. So you have an intro to this if you've watched your fieldwork number 7. So that illustrates a form of tachyometry. So getting horizontal and vertical distances. So the two general equipment we have for Stadia surveying are your Stadia hairs and the Stadia rod. Stadia hairs, the crosshairs, looks like this. And these are the two horizontal crosshairs on a telescope. So this is usually what we see on your theodolite, precise level, total station. It usually looks like this. Sometimes it looks like this as well. Stadia rod, a graduated rod, that's your leveling rod or leveling staff. Okay, so a general term is Stadia rod. Stadia rod. Other terms that we have are Stadia interval, also known as Stadia reading. So it's the distance on the rod between the apparent positions of the two Stadia hairs. Okay, so looking here, again, this is your Stadia hairs. This upper Stadia hair, middle Stadia hair, lower Stadia hair. Stadia interval is the distance between this upper Stadia hair and lower Stadia hair. So when you look at a rod, leveling rod, you'll get a reading. Usually you use the middle part to get the reading, right? So you might ask, oh, what's the purpose of these two lines above and below if all I need is this middle portion? Okay, so that's used to get Stadia reading. So you'll get a reading on this upper portion on the rod. Okay, and then you'll get another reading here, that's the lower reading on this portion. Get the difference of those two, that's your Stadia interval or Stadia reading. Okay? Next, Stadia constant is the distance from the center of the instrument to the principal focus. Okay. So as you've noticed, in our instrument, theodolite, or even precise level, we're using a telescope. Telescope uses lenses. And if you remember from your physics classes, if you have a lens, you have parts to it. You have your center and you have your focus. Okay, so the distance of the center of that lens to the focus is your Stadia constant. Now for older instruments, Stadia constant, which is your C, varies from 0.18 to 0.43. Now, for present day instruments, C is 0.30 if we're using an external focusing telescope, and C is 0 for internal focusing telescope. So remember these values. Again, these are constant because if you notice for a lens, distance from center to foci or focus is the same no matter what situation your lens is in. Okay, so Stadia constant is the same depending on the instrument. Next, Stadia interval factor remains constant and depends only on the spacing between Stadia hairs. So once again, this is another constant property of an instrument. And later on, I'll give you the equation for Stadia interval factor. Next. So when you're using your Stadia, for example, your theodolite, you can get two types of observations. The first type is your horizontal sights. So for example, this is your telescope, this is your rod. Okay, this is the lens at the end of your telescope. Yeah. So from this point, you have your foci or focus here, focus of your lens. And this is your center of the lens. Okay. So distance from this point to this point is your Stadia constant, capital C. So from this, you can create an equation for your Stadia constant, which is small c plus small f. Small c is distance between optical center to center of instrument. So this is your optical center, center of instrument, so that's your small c. And then F is the focal length. Remember again from physics, focal length is the distance from your center of lens to focus. And so equation capital C is just F plus C. Okay, next, other parts. So now we have F, principal focus, small f, focal length, O, here O, optical center, and then I, distance between stadia hairs. So within your telescope, again, there's points here, right? Your upper, lower point, and that distance is your stadia hair I. And over here, I. And then small c, again, distance optical center to center of instrument. Center of instrument, optical center. Okay. And then these are the equations that we need. So K, which is your stadia interval factor, is just equal to F over I. And let's look at the definition again for stadia interval factor. Depends on spacing between stadia hairs. And remember, spacing between stadia hairs is I. So as you can see, and stadia interval factor is inversely proportional to I. And then again, F, focal distance, is a constant property of your instrument as well. And this you already know, C equals F plus C, which is your stadia constant. And then S, stadia interval, we discussed that earlier, that's this, distance between your crosshairs, upper and lower. So that's UHR minus LCR, UHR, upper hair reading, lower hair or lower crosshair reading. And so get the difference between the two, that's your stadia interval. And then D, so D, and it's the distance of your instrument to your stadia rod or leveling staff, so capital D. And this is our equation, Ks plus C. So let's derive how we got that. Because the other equations we can derive just by looking at our drawing. And this is just given, K equals F over I. So let's derive this. Okay. So we can solve that by using ratio and proportion. Okay, so let's take this. And from the focus, I'll draw this. We have this right triangle, right? Or even just this. And then I'll draw another one here. So these two are similar triangles. How do I know they're similar triangles? They have the same angle here. Okay, therefore, we're similar triangles. And then, since they are similar triangles, I can use the concept of ratio and proportion. So that's RNP, ratio and proportion. So ratio and proportion, that's just side over side equals side over side. So let's take this small d, so this side. So I'm just gonna consider and the length. So d over height of your triangle S equals same thing. So we're gonna take the same side. So this length, which is F, over again this height, which is actually equal to I. So F over I. So from this, you can create an equation for D. So D is just equal to Fs over I. And then from this, I can create an equation for D. Just looking at the drawing, D equals small d plus capital C. And once again, capital C is just a constant. Okay, that's your stadia constant. So now I just have to rewrite this in terms of this. So equals Fs over I plus C. But remember, what's F over I again? Correct, RDL and Jasper. It's K. So I can just rewrite this as K. Oops. So D equals KS plus C. And that is how that equation was formed. And KS plus C. Next. So after your horizontal site, if you incline your theodolite a certain angle, you'll get your inclined sites. And then these are the equations that are important. So H equals Ks cosine alpha plus C times cosine alpha, and then D is Ks cosine alpha plus C sine alpha. Okay, so once again, let's derive. Okay, so let's make this clear. So this is H, and this is your H, and then this is your V. And actually, okay, this is your instrument. So let's draw a line of sight. So from this point to this point, this is where your middle crosshair hits. This is the upper crosshair reading, lower crosshair reading. So upper crosshair reading, lower crosshair reading. Okay. And remember the difference between the two, and that's your S. So that's this one. And again, that's S. Okay. So now how to get equations for that? You're gonna use a right triangle. Okay. So this is your alpha. Oh, alpha. And as you can see, I have a right triangle over here. And this length is D. Okay. So again, using this right triangle, you'll see cosine alpha equals adjacent over hypotenuse. Adjacent is this base, which is H. Hypotenuse is this, which is your D. H over D. And then we can rewrite D as C. So this length is C. C. And then this is F. And then this is your D. Yeah. Okay. So C. And then this point is F. And this is D. Okay, see, D equals C plus F plus D. Okay, so let's rewrite that. H over C plus F plus D. Okay, now I can rewrite F plus D. Okay, so F plus D is just this length. Okay, so let's compute for that now. So C. So remember, we have an equation for F plus D. That's just your F plus C. That's your capital C. So I can rewrite your F plus C as the Stadia constant. So F plus C here. So this is just C plus D. And now I just have to get this D. And remember, that D can be rewritten as KS. Right? Because in terms of this drawing, and this is your D, from foci to your leveling rod, D. And D can be rewritten as this, KS. Okay. Now the problem here is our telescope is inclined. So this is the S that B is pertaining to. So let's call that now S prime. Okay? So ito. This length is S prime. Okay? So now I need to get the relationship between S and S prime. And in order to do that, I'm going to create another right triangle. So looking here, okay? So this is alpha because of law of a theory on perpendicular angles. So this is alpha. These two are also alpha. This is also alpha. Okay? And this is also alpha. Okay? So why? So perpendicular angles. So this line perpendicular to this line. And then this line perpendicular to this line perpendicular to this line. So angle between them should be the same. Okay? So theorem on perpendicular angles. So that's why this is alpha. And then this is also alpha. And you got yourself a right triangle over here. So using this, let's redraw that. And okay. So remember, this entire thing is S prime. So I'm only considering this portion. So that's S prime over 2. Okay, and again, this is alpha. Okay. Oh, wait, no. Let's draw it again. Okay. And okay. And once again, this part is just this. And again, this entire thing is S prime. So this portion is S prime over 2. Next, this violet one is half of this total height. So that's S over 2. And then this is alpha. And then from this, I can create an equation relating these two. So I'll use cosine. So cosine alpha equals adjacent. Okay. So in this case, this is your perpendicular side. So adjacent would be S prime over 2 over hypotenuse, which is this. So S over 2. Therefore, S prime, I can cancel out 2. S prime is just S cosine alpha. Okay, and then this is KS prime. Again, I got this from this, wherein S is the angle subtending your scope. So this is the S. I needed to relate S prime to the actual S. Right. So now I can sub that there. Cosine alpha equals H over C plus KS prime. So that's K times S prime, which is S cosine alpha. So S cosine alpha. And then to get an equation for H equals Stadia constant C plus Stadia interval factor K times Stadia reading S cosine alpha times cosine alpha. And then that's how you get that equation. Now let's rewrite that. Ks cosine alpha plus C instead. Next, how about V? So to get V, same thing. You're gonna use this triangle and use sine. So sine alpha equals opposite, which is V, over hypotenuse, which is again V. So sine alpha equals V over, as you can see, D becomes this. So that's C plus Ks cosine alpha. And then therefore V equals Ks cosine alpha plus C times sine alpha. And that's how you got the equations. Okay? So before I move on to the examples, do you have any questions so far? Please answer in the chat. Okay, great. Since you don't have any questions, let's have an example. So number 1. A survey partly proceeded to do their Stadia survey work as follows. The transit was set up at point A and with the line of sight horizontal, took rod readings with the rod at points B and C, which were then measured to have tape distances from A to B 200 meters and 6 meters, respectively. Let's draw that. Okay, so horizontal line of sight, therefore, let's take this as my Stadia. Yeah. Okay. And then we have leveling rods here and here. Okay. And then this is the middle reading. So this is the upper Stadia here. And then this is the lower Stadia here. Okay. And given, so that's at point A. So this is at A. And then B and C. So distances of B and C are 200 and 60 respectively. So this is your B since it's farther away. This is your 200. And then this is your 60. Okay. What else? And then these are the stadia intervals. So stadia interval, again, that's the distance between upper and lower crosshair reading or hairs. So at rod B, that's 2.001. Okay, so that is here. Again, this is rod B. So this is your 2.001. Okay, this length. And then rod C, stadia interval is 0.6. So that's this one. 0.6. Okay. The distance from the center of the instrument to the principal focus was recorded as 0.30. Okay, can anybody give me what variable that is? What part of your stadia is 0.30? Correct, KB Raymar. Escobar Bernardo. Okay, make sure to give me the correct capitalization because there's a difference between capital C and small c. Small c, center of instrument, capital C is your stadia constant. It's correct, remember? Yeah. Distance of center to principal focus is your stadia constant, capital C. So we're given capital C as 0.30. Okay, and what else? Then they went on to survey other points, D and E, and it has the following reading. So the presence of the vertical angle means your instrument was inclined. Okay. And then these are the readings. Letter A, compute the Stadia interval factor. So that's K. So to get this, there's no proper equation for K, right? It's F over I. However, we don't know I. So we can't use that. Not given. So what do we do when the variables we need are not given? We're going to create our own equation. Okay. Right. So we have two rods here. So we can compare equations created from doing each rod. So let's start with rod C. Okay. And then we can create, using this equation, D, which is again horizontal distance for horizontal observation, is Ks plus C. So we'll use this. D1 equals Ks1 plus C. K and C are constants. It doesn't change no matter which rod you're using. Therefore, that's just K and C. Okay. And then, using rod B, okay, so now that's D2. So this is D2 equals, again, K is the same. So that's a constant times S2, sight reading, or Stadia reading plus C. Okay. And then from this, we can compare. We can write D2 minus D1 equals, again, just sub in your equations. Ks2 plus C minus Ks1 plus C. Okay, D2 minus D1, that's just, we can simplify this into, so this is C minus C, this cancels out. And then we'll be left with D2 minus D1 equals, K is a common factor, so I can factor out K. So K times S2 minus S1. Okay, now I just have to sub in my values. D2, again, that's the horizontal distance between instrument and leveling rod or Stadia rod. So D2, that's at B, so that's 200. So 200 minus D1, so that's for rod C, so that's 60, equals K, which is what we're looking for, times S2, Stadia reading, so that's this. It was given 2.001 minus 0.6 for Stadia reading at C. Okay, from this, we can solve for K. Please solve. What's the answer? Correct. Zaira and Zalika. Familiar, Angel. It's 99.93. Okay, now please store that into your calculator. And that's actually the answer. That's letter A. Again, store. Okay, next, letter B. Letter B, compute the horizontal distances DE and DF. Okay, so for D, DF, again, E and F are now at inclined positions. So we can't use the equations for horizontal observations. Okay? So luckily, we have equations for horizontal distance, right? That is Ks cosine alpha plus C times cosine alpha. So we just have to sub in our values. So let's start with horizontal distance from D to E. Okay, so I won't draw that yet. So K, it's this, so use that K. S for E, I think that's given. Stadia interval for E, that's 2.12. So just sub in that. Cosine alpha, let's see. So that alpha is the vertical angle. So that's given 4 degrees, 22 minutes. Plus C given. And then times cosine. Okay. Please solve. What's the answer? Correct. Again, use the stored value, guys. Correct, Kian and Joshel. Joshel. Reyes and Kiben. It's 210.92 meters. Okay, and then let's do the same for the other rod, which is at F. So HDF, once again, K is the stored value of this. And then let's look at the rod reading on F, Stadia interval, 3.56. Cosine, the angle, negative 3 degrees, 17 minutes. Okay, so take note, if you have a negative angle, when you're going to use it in your equation, you're going to remove that negative. So this is now just 3 degrees, 17 minutes, okay? So ignore the negatives when looking for the horizontal distances. And then plus 0.30 cosine. Once again, that's just 3 degrees, 17 minutes. Please solve. What's the answer? Correct. KB and Sebastian. Diego. Cruz Escobar. So it's 354.88. Meter. Now, luckily for us, this was just direct sub, so it wasn't too hard to do. Later on, I'll show you. Sometimes you can't direct sub. And the letter C, compute the differences in elevation between points DE and DF. Okay, difference in elevation. So I'll draw that to show you what's happening. So first, let's draw D and F. D and E rather. So E, vertical angle, positive 4. So that means your angle or your telescope is inclined upwards. Okay? So with a telescope inclined upwards, you'll get something like that. Okay? And then let me set up the landscape. It's supposed to be something like this. And then this is your leveling rod. And this is the reading. So this is point B. This is E. Okay, and then this is what 4 degrees, 22 minutes is. This is your H. And that is what we solve for. And then this is your V. And this is V. Okay? And then, if this is height of the instrument, since we're not given any height of the instrument, we can assume that this and this are the same. So this is also height of the instrument. Okay? So from this, the difference in elevation between D and E is this, right? But since HI is the same here and here, this difference in elevation is actually also equal to this V. Okay? So if I take all of these measurements, all of these heights, and I subtract it by HI, it can be converted to this. So imagine this as your green line, this is still your H, and then this is your V. And as you can see, V now represents the distance or the difference in the elevation of D and E. Okay? So again, if HI, height of the instrument, not given, you can assume this, and then therefore V is the difference in elevation. So difference in elevation between DE is just vertical distance between D and E. We already have an equation for that. So that's Ks. So K, S is the same. So basing it here, 2.12 cosine 422. Okay, plus 0.30. And then the only difference it has with the horizontal equation is instead of cosine, this is sine. Okay, please solve. What's the answer? Correct. John and Jan. So first Kalahon. $16.11. Okay. And then for difference in elevation for DF, that's also just V vertical distance DF. Now this negative angle just means instead of inclined upwards, okay, this is apparently inclined downwards now. So to represent that, it could look like this. So downwards. This is your negative 317. Okay? So that's what that negative means. And as you can see, that's the negative. It will also give you, this will be V. This is HI. This is also HI. Right? And as you can see, I can just plot that downward. I'll bring all of this here to this point. So this difference in elevation between this point and this point is also equal to V. This is now V. Okay? So that's why that's also just VDF. Once again, let's plug in our values. This is still K, 3.56. I'm just copying from the horizontal equation. Cosine 317. Again, you're going to use the positive, just the magnitude. Ignore the sign when subbing into your equation. And again, instead of cosine, this is sine. Please solve. What's the answer? Correct, Zaira, Luis, and Jan. So Lahom, Ortiz. Okay, it was 20.36 meters. Okay, so that's it for number 1. Do you have any questions? Please answer in the chat. Paano po ulit na-derive yung V for DE and DF? How to get this equation? Ito. It's just from this equation. So as you can see, the only difference between H and V is this is cosine, this is sine. Okay, and again, if we're talking about, or if the height of the instrument isn't given, okay, so to make it clearer, okay, so since this is equal, we can assume that's equal if HI isn't given, okay, and this is what we're looking for. So the amount that this goes down is the same, but the same amount this goes down. So this point will be here, and then it's gonna go down by the same point. So this is the same green line. Okay, this is the same horizontal line, and then and this is now your V. And as you can see, V also represents the difference in elevation between points D and E. Okay, so that's why here DE, difference in elevation, equals this vertical distance. Can you use tangent? Yes, you can. If you know H, then you're free to use tangent. You can try and see if you get the same answer. Okay. All right. Next, number 2. Number 2. The upper and lower stadia hair readings on a stadia rod held at station B were observed as 3.50 and 1 meter respectively, with the use of a transit with an internal focusing telescope and having a stadia interval factor of 99.5. The height of the instrument above station A is 1.45 meters. Okay, so given height of instrument here, so our assumption earlier cannot be done here anymore. The rod reading is taken at 2.25 meters. If the vertical angle observed is negative 23 degrees 34 minutes, determine the following. Letter A, inclined stadia distance. Okay, so let's solve. Let's draw first. Also, let's write out our given. Let's write out our given first. We have upper and lower stadia hair readings. So therefore, I can use that to solve for S. Okay, so S is just upper minus lower, so 3.5 minus 1. So now we have S, your stadia reading as 2.5. Next, internal focusing telescope. What's the value of C for an internal focusing telescope? Very good, John and Kian. Kiben Crystal. It's 0. External, 0.30. This is internal, so 0. And then stadia interval factor, that's K, 99.5. Okay, now let's draw. Okay, let's say this is your point A. And height of that is 1.45. And then take note, the vertical angle is negative 23.34. So that means our instrument is inclined downward. Okay, so like that. And then this is where our rod is. This is your B. And that reading is 2.25 meters. So meaning, and this is 2.25. Okay? Yeah, that's what's given. And then let's include the angle as well. So the angle is taken from the horizontal. This is your 2334. Again, the negative just means it's inclined downward. Okay, so that's it. That's all the given. The question first is inclined stadia distance. Inclined stadia distance is this. So you're looking for this D. And then to get D, we have an equation for that, right? If you remember, the reason why we did this derivation is so we can get the equations for all the parts. So again, inclined stadia distance is this green line, that's our capital D. We got an equation for that capital D, which is C plus Ks prime, or just C plus Ks cosine alpha, or Ks cosine alpha plus C. Okay? So D, we can use that here. So part A, D is Ks cosine alpha plus C. So now it's just a matter of direct sum. K given 99.5. S solved for 2.5. Cosine alpha given 2334. And C is 0. Please solve. What's the answer? Correct. KB. Angelica. Angel Escobar. Oh, 2 points ka na. So other one. Maro, correct. It's 2 to 8. And that's it. For stadia distance. Or inclined stadia distance. Next, difference in elevation between the two stations. So this is what we're looking for. Okay. Let's call that DE from A to B. So now I can't use the equation before, okay? Because this is different height of the instruments. So instead, this is what we can do. Okay? So this is V, right? V is from this point to this point. Okay, V is always from the horizontal line of sight of your instrument to where it intersects the rod. So that's your V. I need to get this. So to get that, looking at the drawing, can anybody give me the equation of V? Okay, what's the equation? I want to get this. Looking at this drawing, what's our equation? Okay, very good, Jasper and Diego. Viernes Cruz. Nice. So looking here, you'll see that this height equals this height. So DE plus 1.45 equals V plus 2.25. Therefore, D is just V plus 2.25 minus 1.45. Right? So therefore, that means I need to solve for V first. And we know the equation for V. That is Ks cosine alpha plus C sine alpha. Alright. K given 99.5, S solved for 3.50 up 2.50. Cosine alpha also given 2334 plus 0 sine 2334. Please solve. What's the answer? Correct, Ruben and Zaira. Familiar, Ramirez. Hmm. It's 91.16. Okay, we need that. So store that in your calculator first. And then we can create our equation for DE, difference in elevation between station A and B. So once again, that's V plus 2.25 minus 1.45. Please solve. What's the final answer? Correct, Zaira and Jericho. 2 points ka na, Zaira. So next is Maro. So Tagdaguno, Kasople. So the answer is 91.96 meters. And then part C, the question is find the elevation of station B. If the elevation of station A is 155.54 above mean sea level. So elevation of this 155.54. Okay, so that's easy. So elevation of D is now this height, which is L of A, minus difference in elevation, right? So I just have to get this height minus DE, I'll get this height. So that was 155.54 minus DE AB, which is this. Please solve. What's the answer? Correct, Joshelle and Colleen. Geraldine. Reyes, Lazaro. Reyes, Lazaro. It was 63. Ba't kayo 53? Okay. 63.58 meters. And that's it for letter C. Do you have any questions for number 2? Please answer in the chat. Okay. Mom, how did C equal 0, the Stadia constant? Okay, so looking here, transit with an internal focusing telescope. And then looking at our lecture, for an internal focusing telescope, and Stadia constant is 0. Okay? And so it's a given. If you're given in the problem external focusing telescope, automatic C is 0.30. That's it. Okay. Yeah, I can see it now. Yes. Oh, did I miss one of your messages? Did you ask something? Mhm. Okay. No, I don't think so. Any other questions? Um, really? No? Oh, okay. I've already added corrections for the exam. If you haven't noticed, let me double check. Oh, okay, wait, let me double check. Yeah, I've already given you points for that. So okay, so I think there's still someone who hasn't answered the exam. Okay, but for those who messaged me their corrections, okay, you guys are correct. I've given you the points for that item. Okay, I'm not gonna say which item again because someone or there are still people who haven't answered it yet. Oh, um, man, I haven't given you the point yet. Okay na? Ayan, okay na? Double check your scores. I might have missed giving you the correction. Oh, everybody take this time. The correction about the tower. Please check if I've given you your score. Yeah, I've already checked this. Okay. Uh, I've given you all your final grade for module 1 already. That already includes all of the extra credit scores you've gotten for module 1. So what you see in your blackboard is your final grade already for module 1. For those who got an IEP, I will think about your activity and send it over the weekend. If you have any concerns with regards to that before I move on to the next question. Yeah, I've checked it. Okay, none. Let's have the last example for today. Okay, number 3. An automatic level with an internal focusing telescope was set up somewhere at the mid-length of a long span bridge. Okay, sige, I'll check that later. Bring this up again at the end of the meeting. I'm gonna discuss first. All right, again, the rod readings below were observed on a Stadia rod held successively at the vicinity of the concrete abutments in the southern and northern approaches of the bridge. If the Stadia interval factor of the instrument is 98.5, determine the length of the bridge. So basically, what's happening here is, to simplify, You got a bridge. You have your north-south end. A stadia was placed, or a stadia or theodolite was placed at the center, and then rod readings were taken for each side. The question is, we want to get the total length of this. Okay? Actually, let me draw that better. Uh-huh. So there's no angle given, so we can assume that that is just a horizontal observation. Okay. So at the end on the south side, they got their measurements. Okay. So to get the total distance of the bridge, we can just compute for D1 and D2 and then add them accordingly. Okay. So now let's solve. Let's start with writing the other given. Can you give me what's the Stadia constant? Correct? It's 0. Correct, Geyser and Geraldine. Lazaro de la Cruz. De la Cruz. It's 0 because again, it's an internal focusing camera or lens and internal focusing. So therefore, Z is 0. Stadia constant 0. And then other given is this. Stadia interval factor, that's your K, 98.5. Okay, let's solve D. So remember our equation for D. Let's check out here. That's KS plus C. Okay, again, because it's horizontal observation. Let's start with D1. So K is a constant, so that's 98.5. S is the Stadia interval or Stadia reading. Okay, so we're given these readings. On the south side, it's these, upper, middle, lower. On the north side, it's these. Now remember, for Stadia reading, the only thing that we need is upper and lower. So I can just ignore this middle part. Okay, so Stadia reading for rod at southern approach is 2.98 minus 0.38. So 2.98 minus 0.38. Okay, so let's call that ds for distance from the south side. Please compute what's the answer. Correct. Ruben, KB, John, Ramirez, Escobar. Your 2 points na daw. RDL. Okay, 256.1. Okay, and then do the same thing for DN on the north side. So this is still 98.5. But now the Stadia reading is 3.54 minus 0.98. 0.49 rather. Okay, please compute. What's the answer? Correct. Jericho, RDL, 2 points ka na daw. And then Colleen, Santec, Baguno. $300. 2.5. Okay, and then D, summation of those two. Please solve what's the final answer. Okay, round off to 2 decimal places. So that is correct. Raymar and Zaira Bernardo of Peace. Okay, that's 556.53 since our final answer is rounded off to 2 decimal places. And that's it for number 3. Do you have any questions for number 3? Please answer in the chat. Ma'am, pag DN or DS po ba store values po gagamitin or round? No, always store values. If the answer is not the final answer or if you're going to use it in future computations, you're always going to use the stored value of that or the entire decimal. Only round off in writing the final answer. Okay, any other questions, concerns? Again, all of your grades are already posted. I believe I've checked everything. Let me know if I missed anything. Take this time to let me know for a faster response. By the way, as a reminder, no solution. Your score is just 50%. So I don't mean 50 is your highest grade. No, your score is just 50%. So let's say you got an 80 out of 100, but you didn't upload your solution. So 50% of that is 40. You only get 40. Okay. Correction, automatic. Ah, oh, I remember I've added some. I might have missed a few people because I'm manually adding the score. So let me know. I might have missed some of you guys. So you should see if you check your grade. Oh, okay. Okay. Yeah, I think I've already added. Try to refresh. Okay. That goes for the others. Please check if I've given you the 5 points that you should get since for the tower problem. Right? And haven't missed anyone else? Or no? Mm-hmm. Okay. Mm-hmm. Yes, Momo. Sagot sa bonus. Yeah. My bias in twice is Momo, Hirai Momo, Momo Hirai. Those are all correct. Yeah, modular exam. I'm having you guys check modular exam if I've given you the 5 points that you should get for the tower problem. Really? Oh, okay, since I missed a few of you guys, I'm trying to do it now. So refresh, refresh. Yeah, the one that with the curvature refraction. Oh, you have Momo photo card? Yes. The score in your bonus is already added in the final score automatically. Huh. Oh, I've already given you the plus. Okay, no, I already gave you the iPhone. Okay, no more? Okay, I'll just double check again later. Do you have any questions for me before I dismiss you? All right. Right. So since we don't have any more questions, I'll see you on Thursday. You may go. Goodbye, class.
Thank you, ma'am.
Goodbye, ma'am. Thank you po.
Thank you po, ma'am. Ma'am, no meeting po mo.
No, no meeting tomorrow. Our field meeting will be on Friday.
Okay po, ma'am. Thank you po.
Okay.
Thank you, ma'am. My message